This video is about the project preferences file. And the project preferences file is a file which can save you a lot of time if you use it properly. As you know, we've been talking about all these features in Comosys, with which the macros, for example, you don't need to really enter much information in the macros, and you just basically point and click. And our claim is that this can really save you a lot of time, because if you go inside a macro, there are a lot of things which you need to enter, and these could be things like things which are related to the analysis, which would be things like the thicknesses of plates, or the number or diameter of bolts, or the size of the welds, for example. But then there are other things which are not related to analysis only, but they're related to geometric properties of the elements which are being connected. So, for example, if it was a bolted gusset connection, for example, then the angle gauge distances would need to be entered. Similarly, the tolerance or the distance between the bolts would depend on the diameter of the bolt. So it's very common, for example, to use interbolt distance between in the direction of the load to be around 3D. So if the diameter of the bolt is about 20 millimeters, then typically you would use this to be 60. But if the diameter falls to 16, then you would perhaps use something like 50. So you enter a lot of bolt distance related parameters, and then the bolt tolerances, for example. All these are or the assembly which you need to choose. These things are not directly related to the analysis, but are related to geometric properties of the elements which are being connected. So the project preferences file is a file which saves you a lot of time, because what you can do is you can save away these defaults, if you will, in the file, and then you can go ahead and use your macros without really entering much information. So to explain a bit further, what I will need to do is actually take you through the project preferences file, and then you will realize better what kind of benefits I'm talking about. So let's go to the project preferences file, and it's located under the file menu. And if you go down over here, you see this menu item over there called project preferences. And if I click on that, what it will do is it'll open up the project preferences file. And the first thing which I want to mention is that there are lots of parameters over here, which we will go through most of them, or the important ones. But what I need to say at the outset is that after having set all the parameters, you can give all these parameters a preset name, and the file will be saved away with a different name. And then in different projects, you can recall different project preferences files. So just like the normal presets which we have in Comosys in every command, and the defaults of every command can be saved away. Similarly, the defaults of your project preferences file can also be given a different name, and you can save them away, and then you can recall them later by using the standard menu over here. You can create a new one, you can save it, etc. Now, I won't go over each and every one of them, because most of them are self-explanatory. But the important ones I do want to go through. So let's start off with the design parameters. And in the design parameters page, we have the preferences related to the various design standards which will be used in Comosys. So you have a design standard for connection design, we have a design standard for profile design, and we have a design standard for concrete design. And in the design standard for connections, you have several options which you can use. In the design standard for profiles, once again, you have several options which you can use. And similarly for the design of concrete, wherever those things are. We at this stage, we don't really have many features for design of concrete, but the basic preference, project preference parameter is over there. Now, let's move on to the deflection criteria. And the deflection criteria is for basically the design of profiles, steel profiles. And here you can choose by beam group. So as you remember in Comosys, everything has a beam group. So these blue ones are beams, these brown ones are columns, and the pink ones are purlins by default. You can change the colors, of course. But those beam groups, for each beam group, what you can decide is whether that particular beam group, whether for that particular beam group, a deflection check will be done or not by Comosys. Because when you ask Comosys to do the design, it will obviously do the normal stress and the shear stress checks. But the question is, should it also do a deflection check? So normally, we obviously have a design check for beams turned on. So what you do is you select the beam group and you check this flag over here, which says check the deflection for beams. And then you can tell it how many intermediate points of each segment. As you know, in Comosys, physical elements are divided into segments depending on the intermediate nodes. But each segment will be further divided into 3 points, for example, and it will check the deflection at those points. Another thing what you can do is you can specify a criteria for the deflection limits which are allowable. So there are two main. So imagine an I-beam. So this main direction, the stronger direction, or is the 2 direction, and the weak direction is the 3 direction. So you might have different deflection limits for the strong direction and for the weak direction. So you might have L over 500 for the strong direction and L over 250 for the weak direction. Now over here, this parameter says up to length. So you can also, what you can also do in Comosys is, for example, let me add a row over there. Or actually, in this case, I already have added some rows. So I can just go and modify it. So this is the length up to which, the length of the beam up to which these deflection criteria will hold. So I can say, right now this is 100,000, which means 100 meter long beam, which doesn't exist. So what that basically is telling the program is that for all beams use these criteria, because no beam is going to be longer than 100 meters long. But let me modify that. Let me double click on that and say, for beams up to 5 meters in length, use this criteria of L over, L over 500 and 250. And for beams up to 10 millimeters, or 10 meters in length, I can have another one, which is slightly more lenient. Let's say it's L over 400 and L over 200. And for anything which is bigger than that, so I can enter a very large number over there. And for these, I can say use L over 300 and L over 150. So I can have multiple criteria for the various lengths of the beams for my deflection. And for the cantilever beams, I can have a separate criteria that if you see a cantilever, then use an L over 300 limit. That would be separate from the other criteria mentioned. Now, similarly, if I were to go and select the column, then I can say that for columns, don't do a deflection check. I don't want you to do any deflection check, but I do want to do a deflection check for. So I don't want to do a deflection check for trusses, because the trusses are axial members, and it's the node deflection which I'm worried about, because the individual truss elements don't need deflection checks. But for the purlins, I do want you to do a deflection check, and I can have my criteria. So in this way, using my beam groups, I can give whatever directive it is that I want. So if you move on now to the steel detailing part, which is perhaps the most important part over here, which will save you the maximum time, is that let's go to the plate section. Now, in the plate section, what you can have is you can add as many rows as you want, and you can have for in each row you have a material name and you have an available plate thickness. So the first thing, if you were to start from the top of the tab, it's the preferred plate material. So you can tell Comosys that when you are using your macros, obviously when you go to the macros and you have to enter all those parameters which we were just talking about, and one of the parameters is the material of the plate. But let's say we don't want to enter the material of the plate every single time we use the macro, because you can even forget that, and that's very time consuming and also prone to errors. So what we do is we come to the project preferences file and we choose any one of these materials, We can choose from the material database over there, and we enter that material over here. And then what will happen is that whenever you're using the macros, whenever you leave the plate material field empty, Comosys is going to take the material set over here. If you do enter something, then that one will be preferred. But if you leave it empty, which, as I said in the beginning of this video, that the whole idea behind this click and connect technology in Comosys is that we want you to actually not enter anything in the macros. And we'll go through some of the other features in a second. But the first one over here is the plate material field, and we want you to leave it empty. We just want you to set a preferred plate material over here and then forget about it. And in that project, that material will be used whenever you leave the plate material field empty. Now, after that, we've got these available thicknesses for all the materials. You can add as many materials as you want. So, for example, this material over here, we've got a thickness of 8 millimeters. What this means is that these thicknesses are available in the market. So I'm saying that ST37 has 8 millimeters, 10 millimeters, 12 millimeters, 15 millimeters. So 13 is not available, 14 is not available, 15 is available. And then after 15, 16, 17, 18, 19 are not available, but 20 is available in the market. And then after that, 21 is not available, but 22 is available in the market. So what you do is you can add rows from here, you can delete rows, you can edit a row, you can create a copy of a material, etc. And you can have as many. So all these are for one material. They go down, and after a while the material changes, and then you get the same thing repeating itself. And like I said, you can keep adding as many plate materials as you want. But the idea is that over here, what you enter is your available plate thicknesses, which are available in the market. So what will happen is, let's say Comosys performs a design check, and at the end of the preliminary design check, the thickness which it comes up with is, say, 10.7 millimeters or 12.7 millimeters. Now, obviously, it's not going to take 12.7, but then should it take 13, which is the next bigger integer? But what it does is it will come back to the project preferences file and convert the 12.7 into 13. And look for the 13 over here, but it's the only thing greater than 12 which it will find is 15. So although the results coming from the analysis are 12.7, it's going to go and pick up the 15 millimeter thickness plate because that's the one available in the market. So once again, by using these kinds of techniques, what we are trying to get at is not force you to enter anything in the macro dialog boxes. Basically, some parameters will come from analysis, and then they will be modified depending on the available thicknesses in the market, and some will come from other geometric variables, which we will talk about in a second. Now, after the plates, the next tab over here is the bolts tab, and this is probably the one which is going to save you the maximum amount of time when it comes to not entering anything in the macros is concerned. So over here, what we have are several parameters on the right-hand side, if you see, and these basically tell the macros what to do. So the first thing over there is the preferred bolt material. So just like with the plates, we didn't enter any material, and it went to the project preferences and got your preferred bolt material, your plate material. Similarly, what you're saying over here is that if I don't enter the bolt material in the macros, then you please use this one, this preferred bolt material. But then if you notice over here that two preferred bolt materials, one is the normal preferred bolt material and one is the preferred high strength bolt material. So the macros know which particular macros, which particular types of connections will require high strength bolts, and which ones are typically used with normal strength bolts. Although the old 4.6, 5.6 grades are very seldom used, and everybody uses at least an 8.8 grade, even for the normal strength ones. That's become the common practice. But the idea over here is that you're given two options, and you can enter two default bolt materials. And what that tells Comosys is that if I were to leave those fields blank, which is like, I'm repeating myself, but which is the basic idea, that we want you to leave those fields blank. We don't want you filling those names every single time you use the macro. So what you're telling the program is that if I leave those fields blank, then use an 8.8 grade bolt or a 12.9 grade bolt depending on the situation. Now, as you know, in with the bolts, it's not just the bolt material, but it's also the bolt assembly, which is important. And what the bolt assembly tells the program is things like which particular standard is it going to use for the bolt and the nut and the washer and all that. So that's a geometric kind of the material is the grade of the bolt, but the assembly is basically the geometric standards according to which they're manufactured. So we have bolt assemblies as well besides bolt material, and these bolt assemblies also need to be entered in the macros, as you know. So what we're telling now, what we're telling Comosys now is that if I leave the bolt assembly field empty as well, then use this assembly. And over here also, if you notice, there is not just one field, but there are actually 4 fields over here for the bolt assembly, and I'll be talking about why we have 4. So the first 2 are probably self-explanatory after you see the bolt grade headings. So this is for the normal bolts, use this assembly, but for the high strength bolts, use this assembly. And this is important because usually when you are having a high strength bolt, the assembly also changes. So this will save you the trouble of every time you use a high strength connection, it will save you the trouble of going in there and entering that assembly name. And the reason why I'm emphasizing this is because this is something which actually is forgotten a lot of times, and you end up with a hodgepodge of all these different assemblies, and a lot of mistakes are made by the detailers because it's after all, it's human. You've got thousands and thousands of connections, and you keep entering the bolt assembly every single time, and then a high strength bolt comes along and you forget to enter, or you enter the same one again, or vice versa. So this is a very common mistake, that you end up with bolts which should be high strength getting normal strength assemblies, and the reverse is true as well. But what about these other 2 over here? So in steel detailing, you have situations where the flange, the inner slopes of the flanges, there's a slope on the inner side of the flange. A lot of these profiles, for example, like HEA profiles or IPE profiles, they have a flat flange on the bottom side as well. But some of them, like the UNP or IPE, they've got sloped flanges. And for the sloped flanges, what changes is the standard of the washer. And so you end up using a different assembly for those, and this is one of the most common mistakes in steel detailing, that the detailers end up using the same assembly everywhere, whereas for the sloped flanges they should be using a different bolt assembly. So what these 2 tell us, what assemblies will be used for the sloped flanges, and it once again for the normal slope for the normal strength bolts, what sloped assembly will be used, and for the high strength bolts, what slope assembly will be used. And you can modify these, and once again, like I said, the purpose is for you to not enter anything in the macros, and even these little things, they can end up saving you a lot of time. Now after we're through with that, let's move on to the bolt diameters, and we've got some very interesting things over here which are very useful. And so for example, let me choose the M16 bolt over here. You can add bolts, by the way. You can add as many bolt diameters as you want. But for each diameter, you have the option of telling the program the default tolerance, the hole tolerance. So what you're telling it over here is that if I were to use, or if the analysis was to dictate an M16 bolt, then use a 2 millimeter tolerance. Don't wait for me to enter 2 millimeters in that edit box. And for the same 16 millimeter tolerance, you know that in bolts there are 3 nominal distances which are very commonly used, and these are the edge distances in the direction of the load, the interbolt distance in the direction of the load, and the edge distance perpendicular to the direction of the load. And usually these are 1.5 of the order of 1.5D, 3D, and 2D respectively. 2D in the direction of the loads, 3D in the direction of the loads between the bolts, and 1.5D in the direction perpendicular to the bolts. So what you can say is that if I'm using an M16 bolt, and for the 1.5D distance, which is basically the perpendicular distance, not in the direction of the loads, so what is 1.5D? It's about 24. So you can say use 25 millimeters, for example. And for the 2D distance, which is 32, you can say, okay, 32 doesn't look good, use 35. And for the 3D distance, which should be 48, you can say just use 50, right? So the idea over here is that whenever the program will end up using an M16 bolt, you will not need to enter these distances every single time, and that's thousands and thousands of times. And the advantage would be that your model will come out very consistent. So anywhere there's an M16 bolt, these are the distances between the bolts and the edges of the from the bolts to the edges of the plates. Similarly, if you were to use an M20 bolt, you can say that for the 1.5 use 30, for the 2D use 40, and for the 3D use 60, and that's fine. For the M24 bolt, you might say, okay, for the 1.5D use 40 millimeters, for the 2D distance use 50, and for the 3D distance use 75. And once you enter these numbers and you save them away in your project preferences file, then you can just go and point and click and connect, as we say in Comosys. You can just use start picking up the macros and basically connecting the elements, and it's going to get the bolt diameter from the analysis, the number of bolts from the analysis as well, but the interbolt distances and the bolt edge distances from your project preferences file. So this is extremely useful. And if it's doing a design, you can enter some design related parameters. These are related to your slip critical connections and your reduction factors in case of your oversized holes or slotted holes, etc. These are related to the connection design, but related to the detailing itself, these four numbers over here, the tolerance, the 1.5D distance, the 2D distance, the 3D distance are the ones which will save you a lot of time. Now let's move on to the welds tab over here. And once again, the purpose is to save your time. So as you know, in Comosys, what it'll do is, since it knows the loads because it's connected to the finite element engine, it's going to calculate a weld size for you. Now, this weld size, as you know, in the drawings can be shown to be either the throat or the leg length. And basically, it's the calculation always calculates for the throat size. But if the standard requires you to write the leg size, then it's going to the analysis will convert that into a leg size, and so you need to basically tell the program what you're going to show on the drawings, and according to that it's going to convert it into a leg size or leave it as a throat size. Now there's a fillet weld clearance limit over here, and this is something to do with if you have a 90-degree connection, a T connection between a plate and another plate, then obviously you can do a fillet weld. But if the 90-degree plate is slightly inclined, then the sides are not exactly touching. So if the angle is very small, let's say it's between, let's say, 88 degrees or something like that, then you can still do fillet welds over there. But after a certain point, it becomes more and more difficult to do a fillet weld. So the macro needs to then revert to the groove weld in that case. So you give it a fillet weld clearance limit, and this is the amount which the leg is lifted, which is how much it is not how much away it is from the other plate. So usually this is taken to be about 1 or 2 millimeters. That within 1 or 2 millimeters you can still do a fillet weld, but after that it needs to become a groove weld. Secondly, there's a preference for the maximum thickness for single-sided groove welds. So when you have a groove weld, for example, you can do a single-sided groove weld or a double-sided groove weld. And obviously, for very thick plates, it's preferable to do a double-sided one because it's uneconomical to begin with, the single-sided one. And the double-sided one is not only better structurally, but it's also much more economical. So you can give a number over here, say that after 20 millimeters, if the thickness of the plate is greater than 20, then use a double-sided groove weld instead of a single-sided one. Similarly, you have a preferred weld material. Once again, like I said, the whole idea is to not enter anything in the parameters and leave it empty as much as possible, and allow and tell the program what the defaults will be. So just like for the plate we had a default material, and for the bolts we had default bolt materials. For the weld also, what we're telling Comosys over here is that if I were to leave the weld material or the electrode material empty, then just assume E60XX weld electrode material if I leave it blank. Now I'm going to skip the butt weld section over here. This one you can there's a lot of detail in here which you can modify regarding the sizes of the groove welds. But I'm going to move on for the clearances tab over here. And this is, for example, if you have beam to beam connections, how much do you want the erection clearance to be? How much do you, if there's a notch, for example, typically you want, let's say, 10 millimeters or 15 or 20 millimeters, depending on whatever your company standards are. For a beam to beam connection, you can have an erection clearance. For a beam to column connection, you can also have an erection clearance. And then the good thing about this is that now you won't need to go and enter those distances every time you use a macro. And the second advantage would be that they will be consistent across the board. So in the entire project, you will have the same clearances without really having to work for that. The next tab is to do with the detailing style, and this is once again something which saves you time because, like I said in the beginning, it allows you to not enter stuff in the macros. Now, in every macro, whenever there are plates, the plates are chamfered as well at the corners. And in every macro, you will find that you will need to choose the chamfer type. So do you want this kind of a chamfer or this kind or whatever. So usually, obviously, in steel detailing, these first two are commonly used. But what this will allow you is that once you set this to, let's say, type 2, all the macros will start using type 2 macros, type 2 chamfers, and you won't need to go inside and actually set those chamfer types every single time. What happens in real life is that the detailers they go and enter a particular chamfer type on 100 different points in the model, but for another 100 they forget. So you end up with lots of plates which have these rounded chamfers, and then lots of plates with this type of a straight chamfer, and that really creates a bad that really destroys the consistency of the project. The last thing which I want to mention regarding the project preferences, I mean, there is other stuff over here as well, but I'm not going to get into those. I just want to go to this drawings over here, the drawings tab, and it has this option of loose splice plates, and you can choose whether you want loose splice plates or not. And what this means is that whenever you use the splice connection, the splice plates can be made to become part of the assembly of the beam. Or you can force them to take different assembly numbers. These are two options which are commonly used, and they both have their pros and cons. The cons of having loose splice plates is that you have all these extra. Every plate has its own assembly number, and therefore in your general arrangement drawings you have lots of assembly. Whenever you have a splice, you have to show which assembly numbers. All these there are say 1, 2, 3, 4, 5, 6 plates over there at a very small location, and they all have their numbers, and that creates a bit of a bad looking general arrangement drawing. But the other way you could do it is to not give them any assembly, not give the plates any assembly number, but make them part of the main beam. So the way it is done is by using what we call shop bolts rather than field bolts. We use shop bolts, and in that case, the plates are shop bolted to the main beam and sent along with them. So depending on your detailing preference, you can choose to have loose splice plates or not. So all the things which I've mentioned in the project preferences file, as you must have noticed, are basically to save you from entering a lot of information. All these macros, as we've discussed so many times before, they have a lot of things we need to enter. So, for example, they have thicknesses. These come from analysis. They have bolt distances. They come from project preferences file. So the whole idea is not to make you enter these bolts, because the program will tell you that I want to use M20 bolts and 6 of them, but it won't tell you where to place them. And this is where the project preferences file comes in. So the whole idea is to basically leave everything empty and just select the macro and connect. Now, there's one thing which is not in the project preferences file, but which is very common, and detailers would know this, and that is that when you're using angles or when you are bolting to the flanges of I-beams or channels, you cannot place the bolt anywhere you want. So for angles, for instance, there are angle gauge distances. So for example, imagine if this was an angle of 80 millimeters, let's say L80 by 8, then you cannot put the bolt exactly in the middle. Let's say this one line of bolt. You cannot put it at 40, which is half of 80. The distance needs to be read from an angle gauge distances file, and in this case, I know that distance is 45 from the back of the angle. So every single time, what the detailers need to do with other programs is they need to go in there and they need to write 45. And if they don't do that, by default, the programs will put it right in the middle. And that's wrong, because an L80 by 8 angle does not have a bolt axis at 40, but has it 1 or 45. Similarly, if it was an L60 angle, it would be 35. And similarly, for larger angles, it will be different numbers. And all those numbers need to be memorized. And basically, this edge distance needs to be entered properly. Similarly, if you were working, for example, with, say, a haunch connection, where you have your bolt axes on the where the bolts are bolted to the flange of the column, the location of the bolts cannot be arbitrary, in the sense that they need to be at certain distances from the axis of the column, and those distances are defined in the standards. So these are things which are not available in your project preferences file, but they are available in something what we call the preferences directory over here. So let me just quickly talk about it, because these topics are connected to each other. And the whole idea of having a project preferences file is to not enter anything in the macros when you're using it. And these two bolt distance files are very important, so I want to mention them right now. So let me go to the preferences directory and go slightly roll down, and you will see this angle gauge distances file. If you double click on that and maximize that, what it tells you is that whenever you see an angle of, say, 60, leg length of 60, it could even be an unequal legged angle. So whatever leg is being bolted, it's the width of that leg. So for a 60 leg width, the bolt edge distance, the bolt angle gauge distance is 35, and the maximum bolt diameter which you can use on this leg is M16. So you can see from the top over here as well. Similarly, if you're using an L80 channel, for example, the distance from the back of the angle is 45. That's the angle gauge distance. And you can use an M20 bolt. So don't even try an M24 one, for example. Similarly, for the larger ones, if you cross, say, 110, what you can see is that you have these options over here, that if you want to use a single line of bolts, then it should be placed at 60 from the back. But if you're using two lines, so let's say if you're using staggered bolts, then the first line should be at 40 millimeters and the second line should be at 70 millimeters, and the maximum bolt size you can use is 24. Now, you can obviously customize these, but these are pretty much standard globally. But the point I'm trying to make is that by using this angle gauge distances file, you will further allow Comosys to work without you having to enter anything in those macros. And similarly, just like there was the angle gauge distances file, there is also the flange bolting. This one, flange bolting distances. And this one, once again, we have the profile name. And with the profile name, there's a diameter of the maximum diameter of the bolt you can use, and the eccentric E1, E2, E3 values, depending on how wide the flange is. So if it's, let's say, an HEA 300, you have the maximum bolt size it can take is 27. It can take something less than 27, but it can't take an M30 bolt, for example. And this, once again, is for a single line of bolts and for two lines of bolts if needed, staggered. So 60 and 45 are the distances from the midpoint, from the mid axis. And like I said, the whole point of these two files is it'll just go and it'll check your profiles. It'll check the profile name. It'll check these distances, and it will place the bolt exactly where it needs to be placed. So if you're using a haunch connection normally with other programs, you would be forced to go and enter a certain distance over here. You would be forced to do that, because if you don't, then it'll put the first line of bolts at an inappropriate place, and then you would have to remember that distance for the particular section which you're talking about. But with Comosys, once you have your project preferences file set up, once you have your angle gauge distances file set up, once you have your flange bolting text, flange bolting distances file set out, then you're basically good to go. Half your variables will come from analysis, and the other half will come from these geometric variables which are saved away in your project preferences or your these other gauge distances files. So the reason why I gave you this brief summary of the project preferences file is because this is one of the ways in which you can really reduce your man hours. It may not sound like it's that important, but believe me, it is. The amount of time you waste on entering these parameters for each and every single time you use a macro can really add up. And it can be that I always like to say that the difference if you can do something with one click and you can do the same thing in 3 clicks, that's not the difference between 1 click and 3 clicks. That's the difference between 1 month and 3 months, because that is the amount of time it needs to. It's 3 times the amount of time basically if you require more and more clicks. And if you need to go and enter all these numbers every single time you're using the macros, that's how it adds up, because you don't use them once, you use them thousands and thousands of times again and again. And not only do you end up losing time, you also end up creating an inconsistent model. So my advice would be to please set up this project preferences file immediately when you start using Comosys. Set up your angle gauge distances. I mean, in all probability, the default values will be fine. But if they're not, and if you want them modified according to your own country, then set them up, and then just basically forget about all this and just start using the program.